Hello everyone, welcome to MATHOLOGIC. So today we are going to cover some problems based on real numbers that are meaningful for the classes 8th, 9th or 10th, or you can say they are the previous year questions from NTSE, IJSO, NSEJS, INMO, JSTSE, etc. many more competitive exams, or they have some chances to appear in the further examinations, right? So we are going to just dive in this worksheet and we will solve questions one by one. So today I have considered a list of 15 questions based on real numbers we are going to solve in this session, right? Okay, so the first question which appears on the screen is, what is the HCF of 1 by 5, 2 by 7 and 3 by 11? तो आपको HCF पूछा गया है. HCF कैसे निकालते हैं हमने सभी ने पढ़ा है. HCF निकालने के लिए हमारे पास एक फॉर्मूला है. कभी भी फ्रैक्शंस अगर दिए गए हों और अगर आप लोगों ने नहीं पता है कैसे करना है ये सब चीज़ें, तो जस्ट गो एंड वॉच द कंप्लीट lesson on real numbers in which I have just shown how to find the HCF of fractions like these. So यहाँ पर हम क्या करेंगे, हम सॉल्यूशन में इसके यहाँ पर लिखेंगे HCF of the numbers 1 by 5, 2 by 7, 3 by 11 is equal to just the HCF of numerators means 1, 2, 3 and then the LCM of denominators of these fractions, which means 5, 7 and 11. So this will be our answer on solving. We can get the HCF of 1, 2 and 3 will be 1 and the LCM for these numbers will be a quite large number. As you can see in the numerator there is only 1, so we cannot reduce this further. So I think the option A will be the correct, as we can say the 385 will be the LCM of 5, 7 and 11. These all numbers are co-prime, so the LCM will be the product of 5, 7 and 11, which will be equivalent to or equal to 385. So the correct option for this problem is option A, right? Come to the next problem, which is LCM of 2011 to the power 2011 minus 1 and 2011 to the power 2011 plus 1. तो ये हमारे पास, here we are having two quantities, two numbers. Numbers are 2011 to the power 2011 minus 1 and 2011 to the power 2011 plus 1. As you can see, there are two numbers. If I write 3 minus 1 and 3 plus 1, numbers will be 3 minus 1 is 2 and the next number is 3 plus 1 is 4. Means they are going to be consecutive numbers, either odd or even. So let us just first check whether the numbers are even or odd. As you can see, there is a units place of this number is 1. Unit place is 1, so any power of this number will end at 1. So the number is odd, and again this is the same number, so this will also be odd. So odd minus 1 is even number and odd plus 1 is also an even number. So overall this number is even and this number is also even. Means we are having two consecutive even numbers, and the property of two consecutive even numbers says the HCF of two consecutive even numbers is equal to 2. So we can say HCF of 2011 to the power 2011 minus and 2011 to the power 2011 plus 1 is equal to 2. The HCF will be 2 here, and rest we know the formula that HCF of A comma B times LCM of A comma B, where A and B are two numbers, is equal to product of the numbers, right? We are going to use these properties here. As we know, the HCF is equal to 2, LCM is all we need to find, and the numbers are A and B. Say this number is A and this number is B. Now just put the values here. So this is 2011 to the power 2011 minus 1 times 2011 to the power 2011 plus 1. Now the LCM will be equal to, I am just transferring this 1 over here, so this will become 1 by 2 and times. Now you can see this is an identity, popular identity, which is A minus B and A plus B. So I can write A square minus B square. So this will be 2011 to the power 2011 into 2. Since we are squaring this number, so this will become 4022 and then minus sign and 1 square is 1. So this is the answer. As you can see, this is the option number C. This is the correct answer. So I hope you can understand this problem, right? Next question is question number 3, which says find the unit digit of the sum of these exponents. So first number is 2000 2 raised to the power 2222, and second number is 3 to the power 3333. These are the number. So we are going to use the concept of cyclicity, or you can say power cycle of 2 and 3, and we have covered this thing in the conceptual videos of this real numbers, right? If you haven't watched this video, please go and watch that first and then try to solve these questions by your own. If you have any problem in solving these questions, please do watch the video, and you can stop the video if you know the answer and then solve it. Okay, so we are going to find the units place of these powers, right, and then we will add them up. Now the number is 2 raised to the power 2222, means 2222. So we know the power cycle of 2 is equal to 4, means if we say I can say 2 to the power 1 is equal to 2 to the power 2 is equal to 4. These are the units place 8, and power 4 gives 6 at the units place. These are the number at the units place. So this is the power cycle of 2, means after 4 consecutive powers the units place digit repeat itself. Here also we get the power cycle. The power cycle of 3 is also equal to 4, as 3 to the power 1 is equal to 3, 3 square is equal to 9, 3 cube is equal to 27, and 3 to the power 4 is equal to 81. The units place are 3, 9, 7 and 1, and after that it repeats itself in the order, same order, 3, 9, 7 and 1, right? So if I divide this whole power 2 by 4, since the power cycle is 4, so 4 5s are 20, remainder is 2, carrying 2 here, 4 5s are 20, remainder 2, again taking 2 here, so 4 5s are 20 and remainder is 2, means the units place of this number will be same as the units place of 2 raised to the power remainder, means 2, right? Mark this. And same for this question, this part, we will just divide 3333 by 4, since the power cycle for 3 is also 4. By dividing, we can write this as 3, 4 से divide करेंगे इसको, तो 4 7 जा 48 and 4 8 जा 32, remainder is 1, 13, 4 3 ja 12, 1 remainder, carrying 3 here, we will get 4 3 ja 12 and remainder is 1. So the units place of this number will be equal to the units place of 3 to the power 1. And now you can see the units place of 2 square is 4. So 4 I am getting here as the units place, and 3 to the power 1, which is equal to 3 units place. So 4 plus 3 will be the answer of the whole number's units place, which is equal to 7. So 7 is the answer for this problem, and option A is the correct option. I hope you got this also. Now come to the next problem. Next problem is find the remainder of this large expression, and I have told you how to use remainder theorem in various scenarios. If you are having long expressions, if you need to use cancellation law, or you are doing some exponents. So if you have not watched the video, please go and watch that video, and I will provide the link in the video also in I button, right? Let us solve this problem also. So we are having a number 1071 times, 1072 times, 1073 times, 1074, and this whole is divided by 15. As we know, if I divide 1071 by 15, I will get 7 times 105, remainder is 2 and 1, 15 1 ja 15 and remainder is 6. 6 is quite less than the half of 15, so we can take 6 as the remainder. So on dividing 1071, remainder will be equal to 6. Now this number is 1 more than the previous number, so the remainder will be 1 more than 7 as the remainder, and here this is 72, this is 73, remainder will be 8, remainder will be 9, right? So these are the remainder if we divide individually these numbers by 15, and again we are going to divide this number by 15 since we are looking for the remainder, right? Now we are going to calculate it further. 9 6 ja 54 times 8 7 ja 56. To shorten the calculation, we have just 6 times 9 and 7 times 8. You can either multiply 8 times 6 and 7 times 9, it doesn't matter, we just need to calculate it further, right? So on dividing 54 by 15, we can write 15 4 ja 60. So this 60 number is 6 more than 54, so we can write it as minus 6 times again dividing 56 by 15, so I can write this as minus 4 as the remainder, and again divided by 15, so minus minus gets positive, 6 4 ja 24, positive 24 divided by 15, and now you can see if we divide 24 by 15, we get 9 as the remainder. So you can see C option, which is 9, is the correct here. So C option is the correct in this case, and you know how we have used the problem, the property, which is A times B plus C times D is the number, and we need to divide it by n. Then we can write AR times BR plus CR times DR. Here AR is the remainder when we divide A separately by n, BR is the remainder by we got on the division of B by n, CR is the remainder when we divide C by n, and DR is the remainder when we divide D by n. And then we have proceeded further. Okay, come to the next problem, which is find the remainder of this expression. As you can see in this problem, we have an exponent here. So 2 raised to the power 7799, right, divided by 7, and we need to find the remainder of this expression, right? So if you see, if I power up this 2, so 2 raised to the power 1 is equal to 2, power 2 is 4, power 3 is 8. So I can see if I just if I 3 times the power of 2, I can get a number 8 over here, and dividing 8 by 7, I can get 1 as the remainder. This is my aim, to get 1 as a remainder, so that we can simplify the calculation, right? So on breaking this 7799 in terms of 3, I need to divide it by 3. So 3 2 ja 6, remainder is 1, 7, 3 5 ja 15, 2 carrying 9 over here, 3 9 ja 27, 2 over here 9 29, and 3 9 ja 27. So 2 is the remainder. So we can write this as 2 raised to the power 2 times 2 raised to the power 2599 and whole to the power 3, right? By using division algorithm, we can write like this: 7799 is equal to 3 times 2599 and plus 2, right? So as you know, the rules of exponents, laws of exponents says if we are having base is same and the multiplication, then the powers gets add up like this. We have written in this form this expression, and this is divided by 7. Now this number is equal to 2 square is equal to 4, and this number we can write 2 to the power 3 and whole to the power 2599. Just swapping the powers over here, we can write this like as, okay, just let me divide erase it here. So on solving, we get 4 times this becomes 8 to the power 2599 and whole divided by 7. Keep 4 aside and we get 7 plus 1 whole to the power 2599 divided by 7. As you can see, 7 is divisible by 7, remainder is 1 only. So the remainder over here will be only 1 by using that property qx plus you can say nx plus 1 upon n and whole to the power n. We get 1 as a remainder always. So 7 here, 7 over here, plus 1 plus 1. So 1 to the power 2599 is equal to 1 is the remainder over here, and 4 is the number which is in multiplication. So 4 into 1 is equal to 4. So the answer is 4 will be the remainder of this expression if we divide it by 7. So option D is the correct option, right? Come to the next question, which is question number 6, and it says we need to find the value of this expression. It is quite a good question, and these type of question are sometimes asked in the competitive question examinations. So let us find the solution for this problem. We can see there are 2 square roots, 27 plus 10 root 2 and plus square root of 18 minus 8 root 2. Whenever you see this type of format of the question, just start thinking of making a perfect square out of it. Means we are going to remove the squares which are inside the square root, right? So how to do this? we can make a perfect square inside, which means a plus b square and a minus b square. Since this is minus a over here, so we are going to make a plus b whole square here and a minus b whole square here. So just trying to make this thing over here. Look how can we make this? So 27 over here plus, since we know that a plus b whole square gives a square plus 2ab plus b square. Since this term is not a perfect square, so this is equal to 2ab, which means 2ab should be equal to 10 root 2. Taking 2 common from here, and this 2 will cancel this 2 here. So ab is equal to 5 and 2. So we can write a is equal to 5 and b is equal to root 2, or any possible combination which on a square can give us 27. Since 27 is the square of a square and b square, इन दोनों का सम हमें क्या मिलना चाहिए? 27 होना चाहिए, राइट? तो यहां पर हम लिखेंगे इसको 2 times 5 into root 5, and we can see that a square, which is 25, b square is equal to 2, so 25 plus 2 is 27. We have a perfect square over here. Plus, come to the second part, which is root 18 minus 8 root 2. Again, this must be 2ab. This must be 2ab. So 2ab is equal to 8 root 2. The negative sign doesn't matter over here, since we are going to find the value of a and b only here. So ab is equal to 4 root 2. Now we are going to arrange these numbers in such a way that on squaring a and b we can get 18 as a sum. So we can clearly see a is equal to 4 and b is equal to root 2 will give us the desired result. So I am writing it 18 minus this will become 2 times 4 times root 2. In next step we will write this in the perfect square form. So this will become 25 plus 2 plus 2 times 5 times root 2, and then second square root will become like 18. We can write 18 as 16 plus 2 minus 2 into 4 into root 2. Now see the magic. We can write 25 as 5 whole square, we can write 2 as root 2 whole square, and then we can write 2 into 5 into root 2. A square plus b square plus 2ab, correct? Now this is a perfect square. Same for the second expression. We can write this as 4 whole square plus 2 whole square minus 2 times 4 times root 2. In next step they will become perfect squares of 5 plus root 2 perfect square, and this is inside the square root, plus in square root of 4 plus this is square root over here, 4 plus square root 2 whole square. Now this square will cancel out this square root, same for here, and we can write this as further square root of 5 plus root 2 plus 4 minus root 2. Sorry, this will become negative since this is negative over here. So 4 minus root 2, and root 2 will cancel out this root 2, and we will be left with only 5 plus 4 inside the root, which is equal to 3. So the answer for this problem is option A, which is 3. I hope you got this problem. It is all about the thinking process, how you are going to make these expressions as perfect square, right? So I have shown you the way how to make them a perfect square. Come to the next problem, which is the product of two irrational numbers. It is quite a simple problem, but sometimes students gets confused in what will be the answer, right? So let us consider different scenarios and decide what will be the product of two irrational numbers. So I am taking here case 1, which is if I say two numbers a and b are there, so a is equal to root 2 and b is equal to root 3, then the product of these two numbers a and b will be equal to root 2 times root 3, which is equal to root 6, is an irrational number. This number is irrational, right? Consider this case number 2. This case is if I say that a is equal to 0, since it is not given that the number is non-zero, it is not given over here, so we can take a as 0, b as root 2, but it is given that the product of two irrational, it is saying two irrational number, right? Since a is not irrational number, 0 is rational, so we cannot consider 0 over here. We will be taking a as any other irrational number, so we can take a as root 2. Now a and b both are same, So then the product of A and B will become root 2 times root 2, which is equal to root 2 whole square, or you can say 2. Now this 2 is rational. This 2 is rational number. We have seen that the product of two irrational number is irrational number. In this case, we have seen that product of two irrational number is rational. So this means sometimes it will be rational and sometimes it will be irrational. Now come to the options. Option A says a rational number. No, it's not a correct option. Sometimes we are getting an irrational number, so this is wrong. And irrational number, not always, so incorrect option. Either A or B. Now this seems to be correct since it says या तो वो rational हो सकता है, either it can be a rational number or an irrational, या फिर वो irrational number हो सकता है. Neither A nor B doesn't meet a requirement, so we discard it. So the option number C is the correct option. Okay, come to the next problem, which is, okay, something is missing here. A plus this will be 1 over here. So if A, B and C are real numbers such that A plus 1 over B is equal to 7 by 3 and B plus 1 over C is equal to 4 and C plus 1 over A is equal to 1, then the value of A, B, C is. तो यहाँ पर हमें A, B, C की वैल्यू पूछी है, कुछ यहाँ पर हमें एक्सप्रेशंस दे रखे हैं, A, B, C की वैल्यू फाइंड करनी है. तो सॉल्यूशन विल बी लाइक दिस. We are having three terms here, so we are required to find the value of A, B, C. If you take a look at this, we can see A is over here, B is over here and C is over here. So what if I multiply all these three equations? I will be having A, B, C. So let us do that. Multiplying all these equations, A plus 1 over B times B plus 1 over C times C plus 1 over A, and this will be equal to 7 by 3 times 4 times 1, right? On further multiplying first two brackets, we can write AB plus A over C plus B over B is equal to 1 and plus 1 over B into C. And the third bracket is C plus 1 over A, and the right hand side is equal to 28 by 3. Further solving the left hand side, or you can say multiplying this bracket with this second bracket, we can write A, B, C, and multiplying C with this, so we get A only plus C plus 1 over B. Multiplying 1 over B with all these numbers, we can write this will become A to A cancel, only B here, and A to A cancel plus 1 over C only here, and here 1 plus 1 upon A and 1 upon A, B, C is here, which is equal to 28 by 3. Now what to do? Let us further calculate and find what else we can do here. So I am just writing A, B, C and this A, B, C together, right? So A, B, C plus 1 over A, B, C together in one bracket, and rest of the terms in other bracket with the addition sign, right? So I am having here A, and you can see A is, if combined with 1 by V, we can write it 7 by 3. So A is over here and 1 by B is over here. So write it down, A plus 1 by B. Now we are left with only two terms, which are not only two, four terms are there. So we can write 1 by 1 them. This is B plus 1 by C. These two terms will be equal to 4 as it is given, B plus 1 by C, and the last, which is C plus 1 by A, which is given equal to 1. So this is total equal to 28 by 3. Now substituting all these three values from the given equations, we can write A, B, C plus 1 over A, B, C plus A plus 1 by B is equal to 7 by 3 plus B plus 1 by C is equal to 4 plus C plus 1 by A is equal to 1, and this whole is equal to 28 by 3. So if I add all these three numbers, I will be getting ABC plus 1 over ABC. The LCM will be equal to 3, and I can write this 3 4 ja 12 plus 3 is 15. 15 plus 7 is 22. So 22 over 3 is equal to 28 over 3. On transferring this number or transposing this number to the right, we can write ABC plus 1 over ABC is equal to, this is equal to 28 minus 22 by 3. Since denominators are same, we can just subtract the numerators directly. So here we are getting ABC plus 1 over ABC is equal to 28 minus 22 is 20. 6, only 6 here. 6 by 3 is equal to 2. So we are getting ABC plus 1 over ABC is equal to 2, and we know that if two numbers are like this and their sum is equal to 2, this only implies that A must be equal to 1. This implies A is equal to 1. There is only one solution for this kind of expressions, right? This kind of expression have only one solution, which is A is equal to 1. So from here we can say directly that ABC must be equal to 1, which is the answer. So the value of ABC which was required is equal to 1, and the option C is the correct one, right? Come to the next problem, which says, question is, find the least positive multiple of 7 which leaves a remainder of 4 when divided by 6, 9, 15 and 18, right? So we are having a number. Let us say the number is n. Let us say the number is n. So if we divide this number by 6, 9 or 15 or 18, we always get a remainder of 4, which means if I subtract 4 from this number, then these numbers will divide it completely. Means n minus 4 will be completely divisible by 6. I can write as 6p, since p is the quotient here. So n minus 4 is divisible by 9, 9q. N minus 4 is also divisible by 15, so 15r, and n minus 4 is also divisible by 18, so it is 18r. Now these conditions are true over here. Now this implies that n minus 4 will be divisible by all these numbers, LCM of all these numbers. This implies that n minus 4 is divisible by LCM of 6, 9, 15 and 18. Now the LCM of 6, 9, 15 and 18 is equal to, you can 15, 6 are 9, 3 multiples 90. So n minus 4 is divisible by 90. I can write this as, since n minus 4 is divisible by 90, it means there must be some quotient. So we can write n minus 4 is equal to 90 times capital R. This is the quotient. R is the quotient over here. Or you can say n is equal to 90R plus 4. This is the required number that was asked to us. Now one more condition is given over here, which says the least positive multiple of 7. Now this number should be multiple of 7. Now what we can do, we can just substitute the value of R and can see what can be the value of R. We can divide it in several cases, and we can write R is equal to 1. For R is equal to 1, we can check n will become 90 times 1 plus 4, which is equal to 94. And now we need to check whether this number is divisible by 7 or not. So you can clearly see 94 is not divisible by 7, means this number is not the correct number. Check for R is equal to 2. So n will be 90 times 2 plus 4, which is equal to 180 plus 4, 184. And again, this number is also not divisible by 7. You can use the divisibility rule for 7 and check yourself, right? Now come to the R is equal to 3. So n will become 90 times 3 plus 4. This will be 274. Again, this number is also not divisible by 7. And the last number, which is R is equal to 4, we are checking it, 90 times 4 plus 4, which is equal to 364. Now this is the least number which is divisible by 4. So the required number is 364. So the correct option will be option D, and it is the answer. I hope you guys got this problem. Come to the next problem, which is, we need to find the that this number is divisible by which number, right? So question is 20 to the power 2000. This is 2000, not 20,000. One more zero is over here, that should not be here. Plus 16 to the power 2004 minus 3 to the power 2004 and minus 1. So this is a kind of different question in which It is not being asked that what will be the units place, or you can say what will be the remainder if we divided by any number. It is being asked that what number it divides this expression, right? What is the number which divides this number? So how we are going to find this? We are going to divide it in two cases. So we will discuss it one by one. So case 1 is, we can rearrange these numbers like, 20 to the power, we can write it 20 to the power 2004, and minus 1 to the power, I can write 2004. Since 1 to the power any number is 1, so we can write is 1 to the power 2004, right? There's no harm in doing so. And the second term will be considering this and this. So 16 to the power 2004 minus 3 raised to the power 2004 will be the second term. Now we know that a to the power m minus b to the power m is always divisible. A to the power m minus b to the power m is always divisible by a minus b. This expression is always divisible by a minus b and divisible by a plus b if m is even. If m is even, then it will be also divisible by a plus b, right? So we are going to use these two results over here to find by which number this expression will be divisible. So now I'm going to consider over here that this expression, consider this expression, this is a to the power m minus b to the power m. So this expression will be divisible by a minus b, which means 20 minus 1. So we can say 19 divides 20 to the power 2004 minus 1 to the power 2004, correct? One observation we have got from this expression. Again, consider the second one, which says a to the power m minus b to the power n, by using the same condition that a minus b will divide this number. So a plus b will divide this number since these numbers are even. So we can say 16 plus 3 is 19. So 19 is also dividing 16 to the power 2004 minus 3 to the power 2004. On overall, we can say that 19 divides this whole expression. 19 divides this whole expression. We are getting this in case 1. Now consider case number 2. We are again going to rearrange the terms like 20 to the power 2004 minus 3 to the power 2004, and in second bracket I am considering here 16 to the power 2004 minus 1 to the power 2004. Again, using the one of these results, I can write here that this number is 20 and this number is 3. So I can say a minus b will divide this number. So if a minus b will divide this number, this means that 20 minus 3, which is equal to 17, will divide 20 to the power 2004 minus 3 to the power 2004, right? For the second expression, I can write this number is even, 2004 is even, this is also even. So 16 minus 1 यहाँ पर आपके पास है. So 16 plus 1 यानी कि a plus b will divide this whole expression. We can write 16 plus 1 is equal to 17 divides this number 16 to the power 2004 minus 1 to the power 2004, which means 17 is dividing overall this number, means 17 is dividing overall expression. So we have got two different numbers in two different cases, which means that 17 is also dividing this number and 19 is also dividing this number, which means 17 and 19 both divides the expression, given expression, which means the multiplication of 17 and 19 will also divide the numbers, which means if I multiply 19 with the 7, I will get 7 9 ja 63, 6 here, 7 1 ja 7 6 13, and 19 over here. On summing up, I get 3 2 and 3 323. So 323 will divide the whole expression which is given over here. So we can say 323 is the answer for this problem. So you can see, if you rearrange the terms in two different cases, we have got the answer. Come to the next problem, which says it is quite a popular problem. You can see this problem in your CBSE or any state board you are studying in. So this the solution for this problem is quite easy. the value of this expression, which is never ending, which is going up to the infinity, which is having 5 is square root of 5 is square root of 5 is square root of 5 again, and this is continuing in this manner. So the process that I use to solve this problem, I just name this problem as the process as water, or you can say ocean problem, ocean drop problem. This problem is ocean drop problem. And what it means? It means if we are having an ocean full of water, if I take one drop from it, the quantity of that ocean will never in effect, means we cannot affect the quantity of that ocean by just taking a drop out from it, right? So if I take any number, one or two number out from this sequence, it doesn't matter, it is not going to change the value of this expression, right? So I'm considering this as x is equal to this whole expression. This is now ocean, x is the ocean, right? This whole expression is the ocean. So taking one number out from it, the remaining is this one, which is also an ocean. जो बचा हुआ है बहुत बड़ा है वो, it is going to act like as ocean. तो जब ये ocean है and ocean is equal to x, so I can replace it by x. Now the expression is x is equal to root 5 times x. Now on squaring both sides, we can write it as x square is equal to 5x, or you can say x square minus 5x is equal to 0. Taking x common, we can write x minus 5 is equal to 0. Now this have two cases, either x is equal to 0 or x is equal to 5. Since these numbers are positive and the square root of a positive number cannot be equal to 0, which means the answer is x is equal to 5. So option B is the correct option here, right? It is a quite easy problem, but you need to understand the concept of ocean and drop. Correct. Okay, so another problem over here is question number 12, which is the unit digit of the sum 2002 to the power 2005 plus 2003 to the power 2006 plus 2007 to the power 2007. So I'm leaving this question for you just to solve, since it is based on the cyclicity of the number, or you can say power cycle. So we are having here 2, 3 and 7 as a power cycle. So power cycle of 2 is 4, power cycle of 3 is also 4, power cycle of 7 is also 4. So just divide these powers by 4 and get the equivalent units place, and then sum them up, and you will be getting the answer. Okay, come to the next problem, which is find the product of this this sequence, which is quite, I think there must be some dot over here, since there are some terms missing. This should not be equal to minus, these terms are missing over here. So 1 minus 1 over 6, 1 minus 1 over 7, 1 minus 1 over 8, up to 1 minus 1 over n plus 4 times 1 minus 1 over n plus 5 for n greater than or equal to 5, right? So this type of sequence are called telescopic. These type of sequences are called telescopic sequence, and the name just resemble the property of this sequence. See how solution will include, since it is having this fold, this fold, this fold, this fold, this fold, and you have seen telescope looks like this. In this manner, it have some pair of lenses, bigger and bigger lenses. If you just collapse this, you will be leaving only the first lens and the last lens. You can just compress this telescope like this. So we are going to compress this. Okay, so solve this first bracket. We will be getting 1 minus 1 over 6 will be equal to 6 minus 1 over 6, means 5 by 6 from first bracket, and next bracket will give us 7 minus 1, which is equal to 6 over 7. Next bracket will give us 8 minus 1, which is equal to 7 by 8, and next bracket will give us like terms like this one, and this will give us n plus 4 minus 1, which is n plus 3 divided by n plus 4, and the last bracket will give us n plus 4 minus n plus 5 minus 1, which is n plus 4 divided by n plus 5. Okay, now see, the pattern is 6 cancels 6, 7 cancels 7, and the number 8 will be cancelled by the numerator of the next fraction, which will be over here, and the numerator of this number will be cancelled by the denominator of the previous number over here, and the numerator of this number is cancelled by this number n plus 4, and we are left with 5 upon n plus 5, 5 over here and n plus 5 over here. So we are just n plus 5 over here. So we are getting the first lens and the last lens of this telescope. This is how we call this as telescopic sequence or telescopic series. So the value is 5 upon n plus 5, and the correct answer is option B, right? So if you look at the problem, it is quite large, and we are not be able to solve this, but if we look like this as telescopic series, we can easily calculate, and the answer is equal to 5 upon n plus 5. Come to the next problem, which says the number of distinct prime divisors of the number 512 to the power 3 minus 253 to the power 3 minus 259 to the power 3. तो हमें यहाँ पर इसका क्या करना है, हमें यहाँ पे इसके डिस्टिंक्ट प्राइम डिवाइजर्स का बताना है क्या क्या होने वाले हैं. तो सी हाउ वी आर गोइंग टू सॉल्व दिस प्रॉब्लम. द सॉल्यूशन विल हैव 512 cube minus 253 cube minus 259 cube. If you look these numbers, there is some property between these two numbers. If we add them up, 253 plus 259, this will give us 9 plus 3 is 12, 12 2 here, 10 11 1 over here, and 2 plus 2 4 plus 5 512. So these two numbers give the same number as over here. So I can write 512 cube minus 253 cube plus 259 cube. So I have taken minus common from these two numbers like this. Okay, now I am going to use the property of a cube plus b cube. This is the identity over I am going to use over here. So this says a plus b times a square plus, minus ab plus b square. This is the property. So using this property over here, we can write 253 plus 259, and the second bracket will be 253 whole square minus 253 times 259 plus 259 whole square. This is the this expression after expanding with the help of this identity right here. Now we are going to solve this as, see, I can write this as 512 cube minus, this will become 512, right, product with 253 whole square, 253 whole square, and I can write this as plus 259 whole square minus 253 into 259. Okay, 253 into 259 like this. So there are two numbers, 512 and this whole number. I can take 512 common from all these numbers, so I will be left with only 512 whole square. This will become 512 whole square, and ये number यहाँ से चला गया, बाहर common आ गया. We are left with only minus 253 whole square plus 250 minus, just keep minus outside. So plus 259 whole square and minus 253 times 259, right? So again, these there's another identity we can use over here, which is a square plus b square is equal to a plus b whole square minus 2ab. This is the identity we are going to use over here. This will become 512 and 512 whole square minus, this will become a plus b whole square. On a plus b whole square is what? 512 whole square, and minus 2ab means minus 2 into 253 and 259. Already we are having 1 minus 253 and 259, so this will become minus 3 times 253 and 259 like this, right? I can write 512 as 2 raised to the power 9. 512 is 2 raised to the power 9, and this 512 whole square will be cancelled by this square, right? See, this is minus over here, this is positive. So on taking minus inside, I can write 512 whole square, and this minus minus becomes positive. 3 times 253 times 259. So these got cancelled. Now we are left with only 2 to the power 9 times 3 into 253 times 259. Further, breaking this in terms of primes, we can write this as 2 to the power 9, it's okay, 3, okay, 253. If I break 253, so I can divide this by 11 and the other number will be 23. These are primes, we are done. Now 259, we can divide this by 7 and the other number will be equal to 37, which is also a prime. So now you can see how many primes are there. One prime is 2, one prime is 3, 11, 23, 7 and 37. How many primes are there? 1, 2, 3, 4, 5, 6. So 6 different primes are there which are divisor of this number. So we can say C is the correct answer for this problem, right? Okay, come to the last problem of this video. It is when a positive integer x is divided by 47, the remainder is 11. Okay, so on dividing a number by 47, right? On dividing a number x by 47, the remainder is equal to 11, right? Now it has been asked that if we divide x square by 47, if we divide x square by 47, what will be the remainder? It is quite simple. Since the remainder on dividing x by 47 we get as 11, so I can write x into x divided by 47. Now we can use the result we have studied earlier, which says if we divide the product of two numbers, then we can separately divide them and we can multiply the remainder. So 11 is the remainder when we divide x by 47, so 11 here, and 11 is the remainder when we divide x by 47, so I can write into 11. This is not x, this is into product divided by 47. So 11 into 11 is 121 divided by 47. We can further divide it, so we can write 47 to the 94 and the 94 27 will be left over here divided by 47. Now 27 is less than 47, so this will be the remainder. 27 is the remainder over here. So by using these standard properties of division, remainder theorem, we can find the answer of these problems. So these are the 15 problems which are from the, you can say, previous year questions or from different kind of competitive exams, or you can say these are the most important problems for the upcoming exams, you can see, right? So if you like this video, please do subscribe my channel and share with your friends so that they can also get the information. Thank you so much.